Here's another example of an infinite geometric series where this one diverges. So for this one, we're going to start off by letting n be 1. And when we do that, we get 3 times 4/3 to the 1 power. Then we're going to add the same thing, but we're going to change the exponent to a 2. And then for the next term, we're going to let the exponent be a 3. So we're going up by 1 on the exponent each time. And I'll put a plus ... since that's going to be the infinite series. So for the first one, when I raise that to the first power, it's going to be 4/3. If I raise this fraction to the second power, I'm going to get 16/9. And if I cube this 4/3, I'm going to get 64/27. And then I'll put the plus ... at the end. So now for each term, what I want to do is I want to multiply by 3. If I do that for the first term, I just get a 4 because the 3's will cancel out. For the next term, I'm going to get 16 divided by 3. And then for the third term, I'm going to get 64/9. Now for this series, we need to know the first term, which is a1. We're going to put that on top of the fraction. And we also need to know r, because 1 minus r is going to go at the bottom. We know that the first term of the series is going to be 4. So we know that a1 is going to be 4. But what are we multiplying each time to get to each new term? What do we need to multiply 4 by to get to 16/3? What do we need to multiply 16/3 by to get to 64/9? So that's going to be our r value. So I'm multiplying by r each time. So what is r? I have to multiply by 4 on the top and 3 on the bottom. So my r value is going to be 4/3. But notice that if I take the absolute value of r, I get the absolute value of 4/3. And that's going to give me positive 4/3, which is greater than or equal to 1. Because this common ratio is not less than 1, like the rule says over here, this series is going to diverge. So I write series diverges. Now, if you add up a bunch of positive numbers and every term is positive, eventually you will get to positive infinity. So we say that this series diverges to positive infinity.